Hey guys, okay, we're going to do the video for 5-1, properties of graphs. We want to get a hold of the range domain and all those types of things again. Our eventual focus is going to be parabolic graphs. Okay, let's go over a couple things first. So, just to familiarize yourself with some of this stuff, alright, this is the y-axis, this is the x-axis. I want to label a couple of things. This is a parabolic graph here. All right. And we want to understand what's going on with them. So what we're going to learn to do first is just identify certain properties in the graphs when we see them. Let me just start labeling this graph by labeling this first. This here is negative infinity. This is negative infinity. This here is positive infinity. And this is positive infinity. All right. A couple of things we want to look at here. This here is a y-intercept, or the point where the graph crosses the y-axis. These here, these guys and these guys are x-intercepts. I'm going to move that over that way. X-intercepts. Okay. Then we have our vertex here. This is the point where we change direction. So we're going down and then we start to go up. Then we have, I'm going to try to draw this in the best I can, our axis of symmetry. Okay, that's the point where I could fold this over and it'll be equal, or I can cut it in half and both sides would be the same. All right, take a second and copy that down if you need it. All right, y-intercept, x-intercepts where we cross the x-axis, vertex where we change direction, and axis of symmetry where both halves are the same. Okay, next, let's take a look at an example. So what we need to do here is we need to identify these things. All right, the domain is the limit of the x-axis. So limit of x-axis. The range is the limit of the y-axis. The vertex is the point of change. That's typically what they call it, or where it changes direction. The axis of symmetry is typically the x value of the vertex here. If it was going sideways, it would be the y value of the vertex. X-intercepts, where it crosses the x-axis. Where it crosses the y-axis is called the y-intercept. And increase and decrease are x values, I just want you to understand we're using the x-axis. So understand here, we're only really looking at the y-axis twice. The rest are either coordinates, like the vertex, right? This is an x and y thing, or they're all x values. All right, so let's start with the domain. The domain. This thing's always getting wider. It's always getting wider on the x-axis. This is the limits of the x-axis. It's always going to be getting wider. So the domain is from negative infinity to positive infinity. The range is the y values. So we're going, and notice here, this guy dips but goes back up. So he doesn't go down forever. He starts to go back up. He starts to go back up at -4. So from -4 all the way to infinity, that's our range. From -4, which is the point, that's the bottom point of this graph, or called the minimum, right, to positive infinity. So -4 to positive infinity. That is the range. We do this from least to greatest, so -4, positive infinity. That bracket there says it's included. All right, the vertex, all right, the vertex is this point right here. And that is 3, -4. The axis of symmetry, or AOS, that's going up this way. And we just went over x equals 3. It is a vertical line, so we're going to label it x equals 3. The x-intercepts, that one is where the points across the x-axis. That's 1 and 5. So x equals 1 and x equals 5. The y-intercept, all right, we can't see it, but I would like to go over it. So let's just pretend this guy goes up this way. All right, you guys can write NA if you want, but if we could see where it crossed, it would be like 2, okay? But I'm going to write NA here because we really don't see it. All right, so let's look at increase and decrease. So watch what I do here. This is the x values. As I approach, I'm going to use this here, and I'm going to use this marker. All right, as I leave negative infinity and approach the axis of symmetry, watch what happens. So you see the way this is, my stylus is going down. So I'm going to leave negative infinity and watch it go down. See the way it's going down as I trace the line? All right, so from negative infinity to 3, it is decreasing. So I'm going to say this is increase and decrease. So again, if I can get this to stay still, from negative infinity to the vertex, it is decreasing. So from negative infinity to 3, it's decreasing. We're going to keep a bracket. We're not going to put a bracket on that because it's also included on the increase too. So because it's kind of a point of change, it's almost considered like a flat spot. Next, as I go from 3 to positive infinity, from 3 to positive infinity, from 3 to positive infinity, you can see it's going up. Okay, so that's increasing. 3 to infinity. Okay, and that's answering all these questions. Okay, next. And make sure you can see that on the camera. And looks like we can, right? All right. Next. That's really where we need to be. Okay. So it says here the table of values for the equation y equals x squared plus x minus 6 is shown. What is the one root of the equation? Well, when we look back over here, I'm going to take a look at this one. X equals, this is an x-intercept, and y equals 0 here. All right, y equals 0 at that point. So if we have y equals 0, that's where our roots are going to be. Well, I go down, here's 1, y equals 0. So x equals -3. And my other root is right here because y equals 0. Okay, and x equals 2. Another thing I would like to point out here is watch what happens here as we go past the root. So the root's right here, and the root's right here. Sometimes it is in between what two numbers is the roots. Well, this is +6, then we have 0, and then we have -4. If I took this away, you would just see the 6 and -4. That means the root is in between -4 and -2. Same here. We go from -4 to 6. The root is in between 1 and 3. That's another question that is very common. It's also on this worksheet. Hopefully that will help you with that. All right, I want to go over one more example. This video is a little lengthy. Here we go. This one's going to take me just a few minutes. So I got to find the value of x. I have to use Pythagorean theorem. Well, Pythagorean theorem is a squared plus b squared equals c squared. I'm going to label that x plus 1 squared plus x plus 2 squared equals 2x plus 1 squared. Now I'm going to multiply all these out. X plus 1 squared, right? That means, like if it was 5 squared, it'd be 5 times 5. 3 squared is 3 times 3. X plus 1 squared is x plus 1 times x plus 1. Plus x plus 2. X plus 2. Ooh, I'm running out of room here. And 2x plus 1. And 2x plus 1. That's going to get squeezed in there. Okay, so let's do this. I'm going to write this down here, actually. So I have x squared as I multiply that. Then I go plus x plus 1. Now we're going to do this one. Plus x squared plus 2x plus 2x plus 4 equals, okay, plus, let's see if I can do this without really seeing it, plus 4x squared, and that's going to be plus 2x, then plus 1. Now, I'm going to combine like terms, so that guy and that guy the same, this guy, this guy, this guy, this guy, and that guy and that guy. All right, these two will add up. So on this side, I'm going to have 4x squared plus 4x plus 1. Now I'm going to have 2x squared. Hope you guys are following me along here. 2 plus 2 is 4, plus 1 is 5, plus 1 again is 6, plus 6x. I know I'm doing this kind of quickly, but I'm trying not to make this video last a millennia. Now I'm going to subtract all this because this thing's supposed to be set equal to 0. I can't solve this without it being equal to 0, and I want to keep that 4x squared positive. So that's what I'm going to do. So now I'm going to subtract 2x squared minus 6x minus 5. All right, that's going to cross these out. So now I have equals 0, so that's 2x squared minus 2x minus 4. I have to factor that in order to solve it, but this has the greatest common factor in it. I could take out this 2. I'm going to do that. All right, I got to move over here. So this is becoming x squared minus x minus 2. What multiplies to 2 and adds to 1? What multiplies to 2 and adds to 1? Okay, that's the question we're trying to answer. What multiplies to 2 and adds to 1? Well, the only factors out there of 2 are 1 and 2. I'm going to say x minus 2 and x minus 1. Now, remember this is set equal to 0. Now, if x minus 2 equals 0, that's plus, x plus 1 equals 0. I subtract 1, x equals negative 1. There's that one. All right, and then this one comes out to 2. All right, here's the deal, and I hope you followed that along. I know it kind of got a little crazy here. I'll review it real quick. Since that's negative 1, we can't have that value of x because that's going to make this a negative side. If I plug, or it's going to make me 0 actually. If I put negative 1 in here, okay, I'm going to get 0. That's impossible. This is a physical length, right? We can't have that. So this crosses out. This has to be our answer because when I plug that in, if I go 2 plus 1, I get 3. So that's a length for that leg that's possible. So let's talk about what I did real quick. All right, I used Pythagorean theorem and I plugged in those legs. Then x plus 1 squared, right, I had to expand that to x plus 1 times x plus 1. Then I distributed the whole thing out. Then I combined like terms. Then I set this equal to 0. From there I factored out a 2 because I was able to do that. It's the greatest common factor. Then I factored it by figuring I multiplied to 2 and added to 1. And I got negative 2 and 1. Then I just solved them. When I had x minus 2 equals 0, I solved for x by adding 2 to both sides, and that's what I got. All right, guys. I hope you guys found this video helpful.